Hello students, how are you? Hope all of you must be enjoying staying at home because school is coming to your home. Teachers are reaching you at your home comfort. Okay children, now today I am really very happy to meet you all on this platform. Mr. Vaskinath, your maths teacher, will be taking you to three-dimensional geometry. Today, he'll be teaching you this chapter. I teach you language. Now children, language through mathematics. Okay? Unless you are thorough with your language, you will find difficulty in understanding the meanings of words in other subjects like chemistry, physics, mathematics, whatever the subject will be. One should have mastery in language to understand the subjects. Now see, now Mr. Vaskinath will teach you how to find the foot of perpendicular distance and image of a point. Now look at it. We learn images in English and that is different, and what you learn in mathematics is different. Even you should be able to distinguish between the meanings depending on the context. Now Mr. Vaskinath will be teaching you all these points related to the line and plane. All the best. Have a nice time. Enjoying mathematics. Mathematics is fun.
Hi children. So now I am going to explain how to find the foot of perpendicular distance and image of a point with respect to line and with respect to plane. Both are same under three-dimensional geometry, but first you have to look on the equations of line and equations of plane. Just look on the picture. If you have a line and somewhere a point is P and this line is L. So what we are going to do, this is perpendicular. We are going to find the point Q on the line. This is foot of perpendicular, and this length PQ, which is perpendicular distance, and image. If you are considering this line L as mirror, then image of P will be here R. So here what we have, PQ equals to QR. And same thing we will do in plane. In place of line we will have plane. Now just I am starting with one, and then we will discuss on all the 6. 3 for line and next 3 for plane. Just look here. I will explain with one example. Here we are going to find first foot of perpendicular, because all other 2 points depends upon foot only. Here we have one point P, 1, 2, 3, x coordinate, y coordinate and z coordinate, and this is the line. How we are finding the equation of line? How we are writing? Vector r equals to a vector plus lambda b vector, where this a vector is any point on the line, anywhere, it can be anywhere. And what about b vector? This is parallel to the line, so this b vector is only for the direction. So this is showing the direction of line, and this is one of the point on the line. Now look here, just draw a perpendicular from the point on the line and consider this point as Q. So this point Q is foot of perpendicular. Here I am considering as alpha, beta and gamma. Vertices of point Q is alpha, beta and gamma. Now just look on PQ is perpendicular to line L. Now here we can use the property of dot product. In the vector, if two vectors are perpendicular, then their dot product will be 0. Equation of line given here, and in Cartesian form the same equation can be mentioned as R is x, y, z. This is variable point. So equation of line is x, I, y, j, z, k, and rest all things will be same. So here equation of line, given line, this is given line, x minus 1 by 2. You already have studied about how we are converting this vector to Cartesian. Y minus 2 by 1 and z plus 3 by minus 1. This is equation of line, and it is also equal to lambda. As the point Q is on the line, so in place of x, y, z we can use alpha, beta and gamma. So at this point, at alpha, beta, gamma, we can use alpha minus 1 by 2. Here in place of y, beta minus 2 by 1, and in place of z, gamma plus 3 by minus 1 equals to lambda. So by comparing we can find alpha, beta and gamma, and the values: alpha equals to 2 lambda plus 1. This is the value of alpha. Beta 1 lambda plus 2, and gamma minus lambda minus 3. So this alpha, beta, gamma now in the form of lambda. This alpha, beta, gamma in the form of lambda. Now we can use the property PQ perpendicular to the line. So dot product will be 0. By using that dot product, we have the value of lambda. Here PQ perpendicular to the line L. So the direction ratio of PQ, alpha minus 1, and the value of alpha is 2 lambda plus 1. And second, beta minus 2. This is the value of beta, gamma minus 3. Perpendicular, so dot product of these two will be 0. Hence here directly we can write the vector PQ dot vector B. This is vector B, direction of the line. Vector B equals to 0. Now use PQ vector is alpha minus 1, dot B vector. First I am writing all this: alpha minus 1 plus beta minus 2 j cap plus gamma minus 3 k cap. This is PQ. Dot B vector is 2i plus j minus k equal to 0. Now just multiply and place the value of alpha, beta, gamma. By placing alpha, beta, gamma, 2 lambda plus 1, here we will have 2 lambda plus 1 minus 1. This will be 2 lambda I cap, and by using this one plus 2, this is lambda plus 2, plus 2 minus 2 cancel, lambda j cap, and gamma minus lambda minus 3. So this will be minus lambda minus 6 k cap. Then use the dot product. Now 2 lambda into 2, 4 lambda, and then lambda with 1 plus lambda, and this minus lambda minus 6 with minus 3 plus lambda plus 6 equal to 0. So from here we have the value of lambda 4, 1, 5, 6. 6 lambda equal to minus 6, so lambda equals to minus 1. This is the value of lambda, and now by using the value of lambda, easily we can find the foot of perpendicular. Foot of perpendicular is alpha, beta, gamma, where alpha, beta, gamma are in the form of lambda. So just use that to get the point. What is alpha here? 2 lambda plus 1, and we have the value of lambda. So directly lambda is minus 1, so this will be minus 1. Lambda minus 1 plus 2 is plus 1. Minus 1, so plus 1 minus 3 minus 2. This is the point. So here the point foot of perpendicular is minus 1, 1, 2. Now next, finding perpendicular distance is easy, only we have to use distance formula in between these two, PQ. And finding image also easy, in that we can use midpoint. Just here I am explaining. Now how to find the perpendicular distance. Here this is perpendicular distance. Perpendicular distance is PQ, the length of PQ. Just use that distance formula, simple distance formula. X2 minus x1 whole square, y2 minus y1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is 4 plus 1 plus 1 root 6 unit. So this is our perpendicular distance based on foot of perpendicular. Only to find foot of perpendicular will take time. Now perpendicular distance is easy. Now just look on image also. How we are finding the image of the point. Just consider this line as mirror, and here is point P, any object. So where will be the image? At same distance another side. So here same distance, this point we are considering as R. This is the image of P. So how to find this? Consider the point is x1, y1, z1. Now we can use midpoint formula, P and R. What is midpoint now? For P, R, Q. And these two things are given, 1, 2, 3, and this point also known. So directly we can use midpoint formula to find R. 1 plus x1 by 2 equal to minus 1. 1 plus x1 by 2 equals to minus 1, x coordinate, and from here we have the value of x1. Just simplify. This is minus 2 and minus 3. Now for y coordinate, using y coordinate, 2 plus y1, 2 plus y1 by 2 equals to 1. So from here we have the value of y1, 2 1s are 2, minus 2, 0. And last for z coordinate, 3 plus z1 by 2 equals to 2. Then 2 to the 4 minus 3 1. z1 equals to 1. So the image is minus 3 0 1. This is minus 3 0 1. And in the same way we can find foot of perpendicular to the plane, distance and image for a point with respect to plane. In similar way, now we can find foot of perpendicular to the plane, distance also and image also. Look here, here we have a plane and equation of plane is 3x plus y plus 2z equal to 30. This is Cartesian form. If we are writing in vector, this can be as r vector dot n cap equals to d. Here this n cap is unit perpendicular vector and this d is distance of the plane from the origin. So from this directly we can find the perpendicular vector to the plane. Perpendicular vector is 3i plus 1j plus 2k. This vector is perpendicular to the plane anywhere. It can be here, it can be here. So 3i plus 1j plus 2k is perpendicular vector to the plane. Simply here I am writing this vector is 3i plus j plus 2k. And now look, in this condition this PQ is parallel with 3i plus j plus 2k. So the direction will be same. Now we can write the equation for PQ. For PQ, as for equation of line we have r equals to a plus lambda b vector, where b is directional. This is directional vector. Directly I am writing in Cartesian form. Alpha minus 1 by direction 3 equals to beta minus 2 by the direction 1 and gamma minus 3 by 2. This is for PQ, and the same thing we are considering as the constant lambda. You can use any constant in place of lambda, mu also. So from here we have the value of lambda. Same thing we have completed in line also. Lambda equals to alpha equals to 3 lambda plus 1. Then beta equals to lambda plus 2. And finally gamma equals to 2 lambda plus 3. And this alpha, beta, gamma, this point is on the plane. So in place of x, y, z, we can use alpha, beta, gamma. For plane, the equation is 3x plus y plus 2z equals to 30. Now at point Q, x, y, z can be replaced with alpha, beta, gamma. 2 gamma equals to 30. Now we have alpha, beta, gamma in terms of lambda. So use here to get lambda. 3 alpha is 3 lambda plus 1 plus beta. Beta is lambda plus 2 plus gamma. Gamma is 2 lambda plus 3. 2 lambda plus 3 equals to 30. Now simplify. 9 lambda plus 3 plus lambda plus 2 plus 4 lambda plus 6 equal to 13. 9, 10, 14 lambda. This is 14 lambda, and here now 6, 3, 9 to 11. 13 minus 11 is 2. So lambda equals to 2 by 14, which is 1 by 7. This is the value of lambda. Here again we have the value of lambda. By substituting 1 by 7, we can get the value of alpha, beta and gamma. And this is the foot of perpendicular. Lambda is 1 by 7. So this will be 7, 3 plus 7, 10 by 7. Same thing we can find for beta. Lambda plus 2. Lambda is 1 by 7 plus 2, 9 by 7. And for gamma, 2 into 1 by 7 plus 3. 7 3 is 21 plus 2, 23 by 7. So these three are the coordinates for the point. 10 by 7, 9 by 7, 23 by 7. Now after this, we have the same method to find the perpendicular distance PQ using distance formula, and then the image using midpoint formula. We can find the image of point P as we have completed in terms of line. So for today, this much only, and in next class we'll come with some more topics, some more explanation.
Children, now I think all of you must have learnt the three-dimensional geometry of line and plane. Maths is fun. Have a nice time.